What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at our final lesson of chapter 9, that's 9.6, solving right triangles. So kind of pulling everything together that we've been discussing over the past 3 or 4 lessons. Let's go ahead and get started. We're going to be able to use inverse trigonomic ratios. You want to make sure you've got a calculator handy, especially one that's got the tangent to the negative first power, cosine to the negative first, and sine to the negative first power. Typically, if it already has sine, cosine, and tangent on there, you can also do the inverses of those, okay? First one is just kind of an all-encompassing question. It says, determine which of the two acute angles has a cosine of 5. Remember, for cosine, that is going to be adjacent over a hypotenuse. So if I start with this angle A, adjacent is square root 3 over 2. That is not equal to 0.5. But if I find and look at B, angle B, the adjacent is 1, and the hypotenuse is 2, and that one does equal 0.5. So angle B has the cosine of 0.5. Okay? All right, inverse trigonomic ratios. If we are trying to solve for tangent, if we're given tangent A and we're trying to get whatever that is equal to x, we can select the tangent to the negative first power to be able to find the measure of angle A. A lot of this is just understanding, knowing when to use the inverse operations in your calculator, because a lot of the time your calculator is going to do it for you. So the inverse of tangent for measure of angle A would be BC over AC. Because if you think about tangent, it's opposite over adjacent. So we're essentially starting with the segments BC over AC, and that will help us solve whatever that angle measurement is, okay? So let A, B, and C be acute angles, so we're just going to use some information here to try and solve those degree measurements. The first one says I want to find the tangent of A. So if I want to find the measure of angle A, then what I can do is take the inverse tangent of 0.75. So if I've got my calculator, I would type in 0.75, and then sometimes you have to do shift or second to do that tangent to the negative first power, and it'll give you this number, 36.86, and we're just going to round to the nearest tenth, so about 36.9 degrees. Okay, so just make sure your calculator is calculating the same as mine. If not, you might need to switch it up or use an online scientific calculator. So again, for the measure of angle B, I now want to find the sine inverse of 0.87. So I take 0.87 and do my shift sine inverse. I'm going to get this long decimal, 60.45, so we're going to round it to about 60.5 degrees, okay? And then for my cosine of C, that's the measure of angle C, is equal to the inverse cosine of 0.15, okay? So I type in 0.15, shift, inverse cosine. I'm going to get about 81.37, so we'll just round that to about 81.4 degrees. Hopefully this helps knowing how to type this in. Some calculators are just, you can type in the inverse tangent and then your number, but sometimes you got to do number and then the inverse tangent operation. The next thing we're going to talk about is solving a right triangle. This is the main event of this lesson. To solve a right triangle, it means to find all unknown side lengths and angle measurements. You can solve a right triangle when you know either of the following: 2 side lengths, and that just means we would be using a squared plus b squared is equal to c squared. Or if you know 1 side length and the measure of 1 acute angle, that's kind of when we can do our tangents, cosines, and sines, okay? So we're going to start here, solve the right triangle, round decimals to the nearest tenth. So the first thing I would do to find out letter C is I would take a squared plus b squared and set it to c squared. So that's 9 plus 4 is equal to c squared. This is going to be 13 is equal to c squared, or the square root of 13. And then that is just going to be about 3.6. So C is equal to 3.6, okay? Now, to find the measurement of angles, I might want to start with one of my acute angles. So let's say the measure of angle A, and I am given my opposite and my adjacent. So we're going to find the tangent of letter A. Okay, so opposite is 3 and adjacent is 2. So to find the measurement of angle A, I'm going to find the inverse tangent of 3 over 2, which is 1.5. Okay, so I'll take that 1.5, shift tangent, and I'm going to get about, hang on, 3 divided by 2, yep. So 3, oops, shift tangent. I'm going to get about 56.3. Okay, now if I already know 1, I can then take that and subtract it from 90. So 90 minus 56.3 is going to give me 33.7. Okay, so I've got the measurement of angle A is 56.3, and notice that's my larger angle because it's across from my larger side, and the measurement of angle B is 33.7. Just got to edit that in my notes there. Okay. Next up, solving these right triangles, rounding your decimals to the nearest tenth. So let's go ahead and try these on your own. If you feel confident enough, go ahead and pause here. Otherwise, you can keep working with me. We're going to take 20 squared plus 21 squared, and that's going to give us our x, which is dE. So 400 plus 441 is equal to x squared, or 841 is equal to x squared. And then I just take the square root of 841, which is 29. So x equals 29. So that's part 1 of our answer, or dE. Let's write dE equals x, which is 29. Then I'm going to start with an acute angle, angle D. I've got opposite over adjacent, so I can find the inverse tangent of 21/20ths. So the measure of angle D is equal to the inverse tangent, opposite over adjacent, of 21/20. So I can do 21 divided by 20. I'm going to get 1.05, and then I'll find the inverse tangent of that. And I'm getting about 46.4 rounded, so angle D is about 46.4. And then to find the measure of angle E, I'm just going to take 90, subtract 46.4, and I'm going to get about 43.6 degrees. Okay. Next up, we notice that one of our legs is missing, so we can maybe say x squared plus 91 squared is equal to 109 squared. Okay, and then start to solve here. X squared plus 91 squared is 8,281. And then 109 squared is 11,881. Subtracting 8281, 3,600. This will work out nicely. X is equal to 60. So right here, got my 60. Then I can use those following numbers. In this case, the given numbers, I'm just going to go off of those. So I've got angle G. Let's start with that one. Angle G, my given is opposite over hypotenuse, so that's sine. So I'm going to be finding the inverse of sine when I'm given 91/109. Okay, so 91 divided by 109 gives me an extra long decimal, and then shift inverse sine. I'm getting about 56.6. angle G is about 56.6. So to find angle H, I'm just going to take 56.6 minus 90, and I'm left with 33.4. Okay? The next part we have, you're given some degree measurements already. So this is when we don't have to use inverse anymore. We can just use our normal sign. So if we look at letter H, I want to include the 13. So I'm going to do opposite over a hypotenuse first. So opposite over hypotenuse is so that's sine. Okay, so angle H is the sine of 25 degrees is equal to H over 13. I'm going to multiply both sides by 13 first to find my answer. So 25 sine is 0.4226, and then times by 13, I'm going to get roughly about 5.5 is equal to my H. And then for letter G is adjacent over hypotenuse, so that's my cosine of 25. So again, that's adjacent, G over hypotenuse 13. Now I'm finding the cosine of 25, which is 0.9063, and then timesing that by 13. And I'm getting roughly about 11.8. So G is equal to 11.8 rounded. Okay? Go ahead and try maybe the next one, see what you can try there, and then we'll check it after we're done. So for this one, one thing we can do is, we already know we can find the measure of angle Y by subtracting 90 and 52 from 180. So 180 minus 90 is still 90, and then minus 52 is going to give us 38 degrees. Okay, so if the measure of angle Y is 38 degrees, now I need to find some letters. And maybe I say this letter is X and this letter is Z. Okay, whatever letter you need to do. I'm going to start with my given 52 degrees, and I have an adjacent next to me, so that means I probably want to use maybe opposite over adjacent, so that's tangent of 52 degrees is equal to X over 8.5. So I'm just taking the 52 of tangent, or tangent 52, and then multiplying that by 8.5, and I'm getting about 10.9 rounded. So that'll be X is equal to about 10.9, which is segment YZ. And then to find segment Z, I can do adjacent over hypotenuse. That could be cosine of 52 is equal to 8.5 over Z. This one we've got some extra care done. First I need to multiply both sides by Z. So I'm going to get Z times the cosine of 52 is equal to 8.5. And then to solve my answer, I'm going to divide both sides by cosine of 52. So this is where you just have to be cautious with how you're calculating this. I always like to find 52 cosine first. So that's going to give me 0.61566. And then I'm going to put 8.5 on the top and divide that. So 8.5 divided by 0.61566, and I'm going to get about 13.8. So xy is equal to 13.8. Okay? Last little bit. Your school is building a raked stage. That means add a slant, like so. The stage will be 30 feet long from back to front. Oops. With a total rise of 2 feet. You want the rake angle of elevation to be 5 degrees or less for safety. So this angle I want to be 5 degrees or less. I don't know the degree yet. Is the rake stage within your desired range? Well, x's relation is opposite over hypotenuse. So that means I need to be finding the sine of x to see if it is equal to 2 over 30, okay? Which means if I don't know the measure of angle x yet, I can do the inverse of sine and 2/30ths of that, okay? So 2 divided by 30 is 0.06 repeating, and then the sine inverse of that is going to be about 3.8. So yes, because 3.8 is the degrees, and it's less than 5 degrees, okay? So that's all we had to do there, just applying what do I need here, sine, cosine, or tangent, and then using the inverse when necessary. That's going to conclude our video on 9.6. Hopefully that helped you understand when to use inverse tangents, sines, and cosines, and just when to use them in regards to all-encompassing. Thanks so much for tuning in, and we will catch you next time when we start to review for our Chapter 9 test. Have a great day.